I think I finally got it just perfect. What do you think, Steve? Sorry about that, guys. It's I'm telling you,
It was
this
worth the wait. It was worth the
this
wait. Let's go.
entire competition I've got going on with Mr. Atheist about who has the best hair. I cannot afford to come on to this program with bad hair anymore. So it was a bad hair day. I woke up late, and here we are. But here we are. We are here. We are here, and we have Stefan and Team Skeptic with us. Stefan is new. He hasn't been here before, so we welcome you, Stefan, and welcome back, Team Skeptic. You guys doing okay?
Yes.
Yeah, absolutely. Thanks for having me.
Sure thing. Two things before we jump right in. I'm going to make them fast. I was going to talk about, if you remember, we had a gentleman by the name of Artisan Tony issue Steve and I a challenge at the beginning of the week. He left a comment on one of our videos saying that he challenges us to a discussion on whether or not the Bible teaches a flat earth. And he said that if he were able to prove that it didn't, that Steve and I had to quit bashing Christians. We could not do any more atheist related content, and we had to strictly be anything other than that. So of course we accepted, because we know what it teaches in that department. Well, I don't know if it's that he didn't expect us to answer that challenge or what, but he's been hanging out in the chats. You might have seen him here. He might be here tonight, and he was with us last night. And there's a part of me that just feels like he was looking for a way out of this debate. Like he got into something he didn't expect to. He didn't expect us to take him up on it. And so last night after the show, I got this email. It says, it's really funny. I really got a bad impression of your show tonight when you guys seemed to be humoring the child porn guy. Now, we weren't humoring the child porn guy. We had a guy on here who some people were accusing him of something based on an interview that he did with another individual, and he thoroughly condemned child porn. There was nothing to do with child porn on that level, but Tony's looking for an excuse, a way out. So he says, now, interestingly enough, when I was trying to set up when this debate was going to happen, I said, let's do it next week. And he said, well, no, I'm going to need at least a month to prepare. I've got a bunch of people that I need to talk to, a bunch of professionals that are going to weigh in on this. I need at least 4 weeks. I said, okay, we'll give you 4 weeks. Well, now he says that a few of the people that I have called for my research think I'm not smart by giving flat earth any time of the day at all. Today, I spoke with a Jewish rabbi at the Mizpah synagogue, and he thought it was silly that you even think any religion has the doctrine that the earth is flat. I told him I was just trying to shed some light on a situation for people like me and Steve who seemed to have very little knowledge about different religions, and he still thought it was a waste of time. Now, it goes on. He bloviates for 6 or 7 more pages, but I'm gonna say it's safe to assume that we're not going to get that debate. That his rabbi told him that flat Earth was a waste of time, and he is graciously going to leave Steve, you and me, to find our own way through various religions around the world.
Very nice.
How sad.
Such a nice guy. Thank you so much for that.
Well, Tony, if you ever decide that you want to grow a pair and come back, we'll take your challenge back up. And if you can prove to us that the Bible doesn't teach a flat Earth, we'll close our entire channel. How about that? Then we won't have to bother anybody. So there's you a challenge. Take it up on that. If you think that you can prove otherwise, we'll close our channel. How about that? All right. And number 2, Wolfie has been in trending here lately. Steve, did you see that his video with Flat Out Hero got 3-point-some million views?
He's popular. Yeah, Wolfie's
very
incredible.
Popular. Well, he's coming on next week. He's coming on next week to go through the whole saga with us. So Wolfie will be with us next Friday. I'm excited about that. We're going to talk about what happened with Flat Out Hero and that whole $100,000 challenge. Okay. All right. Now, make up for some lost time and jump straight into what the shape of our planet is. And we have 2 people here. One is new, one is returning. I think people recognize Team Skeptic. But Team Skeptic, please go ahead and introduce yourself for those out there who don't know who you are, and let everybody know what you do.
Well, my name's Team Skeptic. What I do is woo science, not science, science deniers, space deniers, globe denier debunking. All that nonsense. It doesn't come with any empirical data or proof, any kind of evidence that might point towards any kind of science denying hypothesis also happens to conform exactly with what globe heliocentric model says about the planet that we're living on. And, I intend to show that tonight.
Okay, and Stefan, once again, welcome to the show. People in the live chat are saying, "Who is Stefan? You are the mystery man of the hour." So please quell their thirst for knowledge and let them know who you are, sir, and what you're all about.
I'm just a regular guy. I don't have any kind of degree in science background. I grow cannabis for a living, honestly, and out here in California. I was challenged to come on here and talk on one of the forums online, and I'm happy to do so. I feel like the globe specifically is a limited view and tends to apply mutual exclusivity to things that are not necessarily mutually exclusive. Once you establish that the physical nature of reality contains at least 4 or more spatial dimensions, and so I intend to provide evidence that I believe that the Earth is actually more of a hypertorus, like it can project as the flat torus and the 3-sphere, as well as a globe, but they're not mutually exclusive. They're just different projected perspectives of the same ultimate construct. And to do that, I provide sources. I will give you article and paper names, dates, publishing quotes, and only from respected websites: Journal Nature, Space.com, Scientific American, sources like that.
Okay, well, I will say this before we begin. Although we may disagree on the shape of the planet, I am heavily a consumer of your product. So good on you for that. I am I do enjoy cannabis. So in that respect, we are together.
Now.
See, look what brought us all together.
Sorry, go on.
Okay. All right, so Stefan, I'm going to let you take it away, sir. Give us your. I'm excited actually because you will be probably the first flat earther we've had on here to present actual articles and journals for as proof of their concept. So I'm going to let you take it away and not draw it out anymore.
Okay, so I got a lot of notes. You could interrupt me at any time. Some of this stuff is more recent, coming out in the last few months or within the last year. So if at any time there's something that I refer to that you guys are unaware of or haven't read, I'm happy to return to it maybe at a later date. Or if you guys are, referring to something that I'm unaware of. And I also want to make it clear that I'm not here to try to prove anything. I'm here only to support my interpretation of the data, because honestly, I believe that's what science and physics is proofs are mathematical, physics are interpretation of data sets. And that's what you really have to understand and recognize when you're coming into physics is as firmly as you might understand something, there's always a higher level of understanding when you get to that plateau. So I'm going to start off with 2 articles. The first one is from Journal Nature. It was published January 3rd, 2018, and the title is Exploring 4D Quantum Hall Physics with a 2D Topological Charge Pump. And I'm going to quote here the abstract. It's expensive to subscribe, so a lot of people aren't going to want to go and actually get the full article. But just here out of the abstract, you can see they talk about, and I quote, generalize the quantum Hall effect to 4D systems leads to the appearance of an additional quantized Hall response, but one nonlinear and described by a 4D topological invariant, which is the second Chern number. Here we report the observation of a bulk response with intrinsic 4D topology and demonstrate in quantization the measuring of the second Chern number by implementing a 2D topological charge pump using ultra-cold bosonic atoms in angled optical superlattice. We realized the dynamical version of this 4D integer quantum Hall effect. And this is also reported in Gizmodo the next day. And the title of the Gizmodo article is Two Experiments Show Fourth Spatial Dimension Effect. And the second one I'm going to refer to is an article that, again, was originally published in Journal Nature, but you can also find on Avixtra, and that is Challenging Local Realism, the Big Bell Test. And this was published September 24th of January 18, originally, like I said, in Journal Nature. And in this test, they claim that they have been able to close the freedom of choice loophole, challenge causal determinism, and they dispute the hidden variable theory. And so I'll also quote a Scientific American March 2009 article, which is before this, local non-realism was actually firmly established. And that title article is, Was Einstein Wrong? A Quantum Threat to Special Relativity. And they say, and I quote, only a very small minority of physicists grasp that Bell's proof and aspects experiments mean that the world itself has been discovered to be non-local. Moreover, his theory introduces a new variety of non-locality to the laws of nature, a non-locality not merely in space, but in time itself. They go on later and they say quantum mechanical wave function cannot be represented mathematically in anything smaller than mind-bogglingly high-dimensional space. So
Stefan,
that's where
can I
I
ask you a
start
question?
off. What's that?
Can I ask you a question? Can I ask you a question on that real quick?
Yeah.
I'm not what you call, I'm not the brightest crayon in the box. So all of that just flew over my head. Can you, based on where we're at right now, can you kind of put that to me in layman's terms so that I can understand? Because I didn't really grasp half the words. I mean, Steve probably understood what you were talking about because Steve gets all that.
Oh, I got the majority of it.
I
Sure.
understood.
Yeah,
I understood.
but kind of put it for people like me out there that didn't grasp any of that.
So, basically, in quantum physics, especially in quantum electrodynamics, they mostly don't use physical particle. They use virtual particles and interaction through virtual field quanta. And basically, they're just describing a magnitude, a size. That would be the mass of the particle, the magnitude of the wave moving. And I'm going to get into what the wave is later. But they're describing a magnitude of a wave, a direction of a wave, and usually a spin of a wave. And so, this is depending upon whether you're looking at like actual quantum electrodynamics or string theory. It's expressed in a lot of different ways, but when it comes down to it, you can't express the relationship between these virtual field quanta and these virtual particles without expressing the wave at a very high dimensionality of function. So if you try to describe it in 3D, you end up with all kinds of problems. And this is why one of the main reasons that all the unifying theories go towards a higher dimensional expression, because otherwise, for the most part, you cannot rectify general relativity with quantum mechanics. You end up with problems like the cosmological constant problem. You end up with problems like the quantum gravity time problem and paradox. So there's a lot of reasons. Sorry.
Well, one step at a time, Stefan. One step at a time. I'm going to let Team Skeptic respond to anything that he's heard so far. What I want to do, Stefan, is take your points piece by piece so that we don't get too far ahead and then have to come back and try to catch up with where
Absolutely.
we're going here. So let's hit one thing at a time. All right, Team Skeptic, do you anything that you want to say based on what you've heard so far?
Yes. So a few things. Number one, I'm not 100% sure about the different experiments. I would definitely have to do research on those. But about the Earth being non-local, that's be kind of hard to prove, because truly you have to understand everything is really non-local. Everything really exists in a state of superposition. The fact is that when a system is large enough, the superposition, the I would have to say like the variable far the superposition can exist becomes so small that it becomes less than the a Planck's of distance. So while the Earth, you could typically say that the Earth is in superposition, but it's not in a superposition that's enough for it to not be exactly where we would expect it to be. Properties that we observe with, the things that are measurable with things that are, because those things are part of a system that's too large for the superposition really to make a difference, whether you're observing it or not observing it, or measuring, not measuring it. This is defined by the de Broglie wavelength, I believe that's what it is, and by Heisenberg's uncertainty principle. But those two things kind of play together to keep us being able to say, well, when you're not looking at the Earth, or if the Earth is not interacting with a system, it's really where it's at. No, the Earth is too big to not really be where it's at. An electron, on the other hand, yes, we could say that about an electron. We could say that about certain small particles that are larger than single atoms, but still anything that gets, much, much larger, it's going to be hard to put it into superposition, and to be able to test whether it's in superposition or not without collapsing the waveform into a measurable reality. So I would have
Can I
to do more
paraphrase
research.
that? Can I paraphrase that in a much more concise way, team? Because you
Yeah,
got the
for sure.
gist, but it's much simpler than that. You're right about the de Broglie wave, a matter wave. When something is small enough, which it's small enough, so its quantum mechanical superpositioning is within the matter wavelength, you don't experience macro quantum effects. Simple as that. So if something is small within its
Obviously.
own wavelength, right? The matter wave, the de Broglie wavelength you're talking about. When something is that small, it doesn't no longer exhibit, or actually, if it's bigger than that, it no longer exhibits quantum mechanical effects. So in the macroscopic thing, we don't see superpositioning of macroscopic objects like that typically, because it's outside the space of that wavelength of the matter wave. More succinctly.
So my question is, when you see something, are you seeing the actual object, or are you seeing the representation in your brain of that object, which is the object's effect on you and your consciousness? Once you've established that consciousness itself has the event horizon singularity, it becomes a quantum mechanical wave function problem. You're
No.
not
Entirely
observing,
different question, but no,
you're observing your consciousness observing the Earth.
No. You're getting the observer effect and opting completely wrong. Are you very familiar with quantum mechanics, or are you just trying to interpret what you've seen before?
No, I'm fairly familiar, and I would refer you to an article titled Consciousness in the Universe is Scale Invariant, Implying Event Horizon in the Human Brain, and that was published in Neuroquantology. Look at the exact date when that was published. But I mean, I'm no expert, but I've read. I'm fairly familiar. I'm
Okay.
familiar enough.
Well, let me inform you a little bit about what the observer effect really is, because there's so many people get this wrong. It's probably one of quantum mechanics' most misinterpreted events, or like things that happen in quantum mechanics. It requires nothing of you observing, or whether it's you looking at it, or an animal looking at it, or a camera looking at it, anything looking at it. It means nothing. Because let's say you have a photon, right? A photon is traveling parallel or perpendicular to your line. Would you ever know the photon was there? No, you wouldn't, because the photon has not interacted with something, and you are not receiving information about where that photon is. So the act of observation is really just a reading of information is being leaked from the interaction of two quantum systems. Okay, so have the information leaked, but you have no observer, you're still going to have a collapse of the function. Okay. If you have an observer, but you have no interaction, no two interacting, then you're not going to have a collapse of the wave system. And this is easy to prove, okay, because they sell little bitty laser. You could take a little laser and two slits in a piece of paper, and you can show how you can turn that one laser to from a beam of light into the wave, the wave function probability, the probability function. You can put this on the wall and see it all. Now you're looking at it, so by definition this should go into superposition, because you have the ability to actually watch the laser do this. But the thing is that you're not really getting information from that laser about which of those slits the actual laser went through. That's why it's in superposition. It has nothing to do with your observation whatsoever, and everything to do with whether or not you have the ability to get information about which slit it went through.
And that's why
what the
I
observer
referred to first the article that was titled Challenging Local Realism with Human Choices, which is not about the observer effect. It is specifically about local realism in aspect and relationship to human choice and human consciousness, which is human perception.
Realism has been disproven a long time ago with Bohr versus Einstein. Like, we're not here to say that Einstein's theories on materialism, or the spooky action at a distance, the things that he got wrong about quantum mechanics. We're not prove that, because we can both agree on that. I understand it, that idealism is going to take hold quantum level, but it still does not keep us from being able to use the universe around us, the area around us, to make observations, and based on those observations that happen to be right every time we make a prediction.
So you both agree,
Okay.
local realism. Einstein got wrong on that. We all agree. I mean, you kind of foster this along, because that's why we're going to move on real quick. That's why I just wanted to get this out. This has nothing to do with the shape of the Earth. Most of us are Copenhagen interpretists. We accept the Copenhagen interpretation. If you want to go to multi-world hypothesis, that's fine. No local hidden variable model satisfies the Bell inequality. We all accept that. Local realism is over. What does it have to do with any of this?
Okay, so as I
agree with that, by the way?
I do. Moreover, okay. I was trying to establish that space and time are constructs where, and again, here I'll refer to another article in physics from physics.org titled "Scientists Suggest Space-Time Has No Time," where they look at space-time as not 3 dimensions plus time, but 4 dimensions with time as only a rate of change or a rate of displacement. And to compound with that, I will reference.
Can I ask you one thing? Because we're trying to the shape of the Earth. Okay.
Yeah.
Now, I know you're going to be reading. Go ahead.
We're getting there. We're getting there. This is a very complex problem, a complex answer that you're getting. You can't, if I just say, oh, the Earth is a hypertorus and you could see it as a flat 3 torus, there's no basis for that. First, you have to establish the basis. So as I was going to say, the second one I was going to refer to is a article or a paper written by Dr. Frank DePlace talking about how, and it's titled "Liquid Space-Time Viscosity: A Way to Unify Physics." And they build off the demonstration that general relativity tensors and the Navier-Stokes equations can be identical. By applying fluid dynamics, you can calculate a dynamic viscosity for the space-time medium itself. In doing so, they basically found that the only way to make the numbers fit, where it was scalable at any level and invariant, was to assume a universal critical density higher or above critical density. And so if you start thinking of space-time itself as a hyperdimensional fluid medium, and then you start getting into relativity, about relativistic motion and what it means for us to be able to have this relationship with light. Everything you observe is a radiation of some sort for the most part. It's light, even if not in the visible spectrum. And you first have to establish what is the nature of light that you're seeing. And so if light is only a propagation through this medium, like a disturbance, a perturbation, a wave, you could call it whatever. In I believe 1917, Theodore Kaluza was talking about how you can see light as a ripple from the fifth dimension, meaning it is able to move through more spatial dimensions than you or I can physically observe in 3 dimensions. And in an article titled "The Donut Universe Bites Back," also published in journal Nature, I believe in 2008.
All these are just hypotheses. None of them are actual theories or workings.
Well,
or
no,
anything
hang on. The Stokes equation is very legit. But he said donut.
Yeah.
The Stokes equation is literally very legit. But I took thermodynamics and I don't even fully understand the Stokes equation. I know what it does.
I'm not even talking about that thing. I'm talking about the universe being donut shaped and all this other stuff. Like, it has nothing to do with the shape of the Earth.
It does if you establish a unified field theory that works invariant at every scale. And you have established that the universe has the shape of a 3 torus. Again, quoting journal Nature, it's possible to have a shape of a 3 torus universe. And in my opinion, the cosmological axis of evil, which is mapped by both the WMAP and Planck satellite data, is pretty good evidence that even though it appears flat and finite to us, there is a 3 torus structure to the universe. They've also modeled, the toroidal model of the electron. So I know he gets a lot of shit in the scientific community, but personally, I really like Ken Wheeler's theories and his unified field theory, describing the actions of dielectricity and magnetism as the toroid hyperbolic conjugate are very easy to apply on a invariant universal scale. And so once you've established this, my hypothesis, coming back to the actual point, is that what we would call a gravitational field or an electromagnetic field of Earth is basically at the edge of the Van Allen belt, at the edge of our magnetic field where our gravitational field drops below 1%, there's essentially an asymptote. And my theory would be that this is where the space-time loses coherency. If you think about water coming down a drain, you pull the drain in the bathtub, you got water on one side that won't drain, you got water on the other side that drains. And it drains in a spiral fashion, being pulled, in this metaphor into the center of gravity, basically. So if you have a 4-dimensional superfluid being displaced into the center of gravity of this Earth field, we are experiencing basically the 3-dimensional physical shadow of that field. And so that shadow will change due to matrix transformation with your perspective. As your perspective changes and is projected through different densities and geometries of space-time. As you get away from the Earth, you're looking back through curved, inhomogeneous space-time, which is not the same as if you're looking at the surface. There are different projected perspectives through this transformation matrix.
Okay. Stefan, well, how often do you enjoy your product yourself?
Every day,
all the time.
Okay. Go ahead, Team
Skeptic.
Go ahead, Team Skeptic.
I need to start enjoying that product. I'm telling you.
You do, Steve.
Go
ahead.
I do.
I was going to say that, all this isn't theoretical and everything, but we really need to get to the discussion. The discussion is going to be, what is the shape of the Earth and how do you intend on proving? Everything you've said so far is basically the same thing as simulation theory. It holds the same weight.
Absolutely.
As
it's very much in line with that. It's very much in line with simulation theory.
Yeah, I can tell from the way you're talking about things that you're suggesting mathematical lattices to to kind of make sense of higher dimensions of 4th, 6th, 7th, and 8th dimensions, things of that nature. So, but that doesn't help us with what we're here to talk about. Tonight, we need to talk about the shape of the Earth and all that, unless you're going to tie it all into the action of the Earth and how we can make predictions based on the model you're prepared to present, or even, you know, the model to just argue for, even if it's, you're not here to present an physical model with all the answers. If you're just here to at least argue the point of the shape of the Earth, I'd be more than happy to entertain.
The shape of the Earth.
Or I can go with my first proof, and you can follow with that.
I say that the shape of the Earth is a hypertorus, which projects as from the surface view as a flat torus in the 3-sphere, which is topologically
then
3D sphere.
Then we can agree that you look out and use flat, and that's how you make your base your prediction, correct?
Essentially, yes.
Okay, so can I go ahead and start then?
Yeah, go for it.
All right, good deal. So for my proof, you and I both, we're going to do this together. We'll be calculating the height of a communication satellite. Now, the satellite in question that we're talking about is DirecTV SL3 LBN, and it's responsible for delivering digital television to a portion of the United States, but also specifically the Southwest, right up the middle of the United States at Alaska, Hawaii. The receiver, the way satellites work, I'm sure I'm going to say this for everybody else, because I'm sure with what you've done, you already know how radar signals work in satellites and whatnot. But the way these satellites work is they beam a signal down to Earth, and as the wave propagates across the surface, you have individuals' homes, and these receivers are pretty much line of sight receivers. Okay, it's important that they're line of sight receivers because you have to be pointing the satellite receiver at the dish in order to be able to get the signal, to make the signal usable. Now, picking the satellite out to do it is because we can agree that there's DirecTV customers out there that are getting their signals at home properly, right? Is this correct? Would you agree with that?
Yeah.
Okay, good deal. So we assume that whatever numbers we get from this satellite, that they would actually conform, or they would match up with the math that agrees with the shape of the Earth, correct? You there?
Yeah, I'm here. I'm listening.
Okay. All right. I'm just trying to get you, I'm trying to walk you through this process. It's kind of like a lawyer getting you to agree to a bunch of stuff. So that way at the end, when I drop that hammer, I say, hey, you agreed the whole time. Why are you disagreeing now? So, okay. So for accuracy purposes, what we're going to do is we're going to use dishpointer.com and csgnetwork.com as websites that will give us information. I'm sorry.
Before you continue, can I ask one question?
Yeah.
Are those measuring radio waves, light, radiation propagation, or are they measuring physical metrics?
Okay. Do you know how a transceiver or a receiver works with radar technology?
Yes, absolutely. So that's why I'm asking you.
So
are they observing radiation frequency?
It's observing the waveform coming from the satellite. So in other words, if let's say you were to take your receiver and you turned it 45, you'd no longer be looking at the signal. Now the signal would be taking it to the actual to the receiver, but it wouldn't actually be usable because it wasn't facing the radar. And if you dropped it in elevation or you raised the elevation, doesn't matter. As long as you're not line of sight to the radar, you will not get them.
Yeah, so I would say if you're familiar with what a null geodesic is in general relativity, it states that the light will follow the curvature or displacement in the space-time. And that kind of gets back to the whole point of that, we aren't spinning through space-time. Space-time is spinning around and through, displaced into the center of the Earth. And when you look to that satellite from here to there, you are observing space that is curved beyond the dimensionality of those three-dimensional receivers to observe. And you're calculating for a curvature which is inherent in the space itself, not necessarily the Earth. And that it gets back to really the whole idea of relative
space-time. The curvature of space-time at that point is not curving so significantly, and a crazy amount of difference on what you're observing. You're actually looking at the satellite. Go ahead.
You're looking that upon a three-dimensional measurement of a fifth or higher dimensional wave function. I would completely disagree that you can accurately chart the path that light has gotten through
Okay.
to get to you.
You know what? Not a problem. Not a problem. I'm about to prove how we can. Can you please pull up picture number 1, please? And I'll give him time to make sure that he's getting that the picture is up.
Are you able to see any images,
Okay.
Stefan? That's the,
No,
I
I
don't know if
can
he'd
get
be
on
able to see
YouTube.
them.
Yes, that's.
Yeah, no, as I said, I can't see an image. I can get on YouTube and try to pull it up, but I
Okay,
I don't have.
if you do that,
see anything.
if you do that, just make sure that you turn your the volume down from whatever you're playing it off of, so that it won't echo through. Just follow the sound with the call and watch with whatever you're going to. Just turn that volume down on that.
Okay, I got the.
Oh,
Like I said, man, like I'm trying to load it here. I got the volume down. We'll see if it plays. Give it a second.
Okay.
okay. Well, for people that are watching, I'll go ahead and start describing. We're just looking at numbers here. First picture, I am showing the satellite point. Now, a sub-satellite point is a position on the planet that is directly below the satellite. Now, for this particular satellite, the sub-satellite is on the equator at 101 west longitude. As you can see, the azimuth is at degrees and the elevation is at 90 degrees. Now, what azimuth means is it means where, like a horizon, where would you be pointing the radar? Okay, so 0 would be north, and this is geographic north, not mag north, but 0 would be north, 90 would be due east, 180 is due south, 270 is due west, 360 is due north again. And the elevation is the amount of degrees you must tilt the receiver up from the horizon, where 90 degrees is straight up and 0 degrees is on the horizon, perpendicular to the receiver's plumb line. So at this position, the satellite is due north and direct overhead. So basically, you're looking at on the equator at 0 north, 1 west. You're going to be staring straight up, and you're going to see this satellite. Now, it's key to note that these satellites are geostationary, which means that they remain above the exact same sub-satellite point on Earth at all times. If this satellite was to move, millions of people would know, and millions of DirecTV customers know immediately when the satellite moved. And this would be the same no matter what the shape of the Earth is. So in other words, if the Earth is flat, what the DirecTV satellite's directly over this point on the flat Earth, whether it's shaped like a toroidal field or whatever you want to call it, absolutely at this point still look up and see this satellite. It's not going to be on the other side of the donut. It's going to be on the same side every time because it has to be there. And they're all approximately 35,000 kilometers up. Will you go to pic 2, please?
I still can't get up anything on my screen, but you can keep going. It's all good.
All these are just pointing out numbers, really. We're pulling up numbers to build a three-dimensional of what we're seeing. Okay, so in this picture, we get the data from different locations to see how the receiver's azimuth and elevation changes. So it degrees north and 101 west, which is 30 degrees due north of the sub-satellite point. The azimuth is 180 degrees and the elevation is 55 degrees. At this point, we would need to know the distance between the 2 points on them. For that, we will be using the National Hurricane Center's land distances calculations between 2 GPS coordinates. It's accurate on a flat Earth within the northern hemisphere, but across the equator, you can't use these numbers for flat Earth calculations. Let's see. All right, so now that we have these numbers, we can make 2 calculations here. One we'll make for a flat Earth and one for a globe Earth. Will you go to pic 3, please?
Right, your flat Earth is again it's not Euclidean flat. It's you're kind of misrepresenting the whole argument, because as I said, a flat 3 torus is topologically identical to a 3D sphere. So all of the globe math will work identical with the flat 3 torus math. Due to the Poincare conjecture proof, it has been proven that they are topologically identical. You cannot say the geometry or trigonometry for this one will work, but this one won't because the concentric
You
circles
can
past
make
the equator,
okay.
north and south on both sides, get smaller on both models. I'm not
So
saying
here's the
that.
thing. Here's the thing about science is designed to give you predictive models. Okay. So the model that you're suggesting would need to have the same powers, if not more predictive powers than the model that I'm suggesting. All right. So I'm giving you a way of testing the shape of the earth, the geometric shape of, and this works no matter where you go on the earth. Okay.
It works from a limited perspective with physics that only work within our solar system. These physics fail at the galactic scale, they fail at the universal scale, and they fail at the quantum.
What proof do you have of this? What proof do you have of this?
The fact that dark energy still hasn't been measured after 50 years of looking for it, and it, dark matter and dark energy make up 95% of the universe.
That
Why?
doesn't mean
because
that it'll never. That does not mean that it'll
know.
be measured. So you can't, just because we haven't measured it now doesn't mean that it does not exist. Because the time before we knew photons existed, did they not exist as well?
Necessarily.
All right, one at a time. One at a time, guys. One at a time. One at a time.
Well, I mean, I'm just saying that I'm saying that what I'm doing here. Okay, when we get done, I will show you, definitively that you can use the model of the Earth being a sphere of approximately 6,371 kilometers of radius. You use that model and predict exactly where to find this satellite, where you are on Earth. Now, can you do something better than that? Okay, can you
prove the globe, Earth, that is actually curved rather than space-time that is curved around the Earth? Okay, and so again, coming back to the fact that
I don't believe I have the burden of proof on that. I believe I am proving that with my measurements. Now, I can continue if you'd like me to, and show you that this works perfectly on a globe Earth and has problems on a flat Earth.
Again, it works at one scale in the universe, locally, with numbers that we've assigned and guessed. It does not work universally at every scale. The difference is the model that I'm proposing does work at every scale. That's what makes it better. It's not that that your math doesn't work in a small subjugated section of science when you look at it, with partitions on and you isolate everything. Of course, your math might work.
This is not a small subjugation section of science. Okay, we base many scientific calculations on the physics of our world. Okay,
and
now
again,
these includes gravitational pull. This includes the shape.
Explain the galactic rotation. Explain the galactic rotation curve problem without dark matter or energy. Explain the cosmological constant problem being off by a factor of 120 magnitude without dark matter and dark energy. Please rectify the quantum gravity time problem.
Okay, you're saying you have to explain something without using something that has neither been proven to be true nor proven to be not true.
I'm saying that, again, I'm not talking about proof.
We can sit here and we can like shit up the whole time and just say, oh yeah, look, dark energy is not true because no one's found it yet. So what does that do for our universe? What kind of qualifications do you or I have to make that assertion when there's PhD physicists that are actually working on these things?
Okay,
so let's get back to what
the idea of dark matter and dark energy is to explain the missing mass that would be needed for gravity to fit and not either implode upon itself or explode. Okay, so once you start thinking of space-time itself as not not as a metric, but as a physical entity, and again, they calculate the dynamic viscosity. The viscosity is super high when they use general relativity and the Planck equations. They come up with a density that's almost as thick as honey. So when you start thinking of the space-time itself as a thick medium, you don't need dark matter and dark energy to explain missing mass energy. Once you have established that,
I would love to sit here and talk about this all day long, but these people want to hear us talk about the shape of the Earth, and that's what I'm here to talk.
Well, again, you are trying to isolate this into a very small box, which is the biggest
No,
problem
no,
that
no, no,
science.
no, 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 no. No, it's not a small box. We're here to talk about the shape of the Earth. Okay. Now
Okay,
you're
but they're
talking about it. You're talking about it
Torus.
roidally shaped with a flat representation, or I still don't completely understand the nonsense spewing. I understand that you probably read a few things and you're interpreting the things you'd like the way you'd like to interpret them, but I don't think that you're qualified to really interpret those to make assertions based on those interpretations.
Your argument that you don't understand my argument is not a valid rebuttal to my
No,
argument.
no. I'm not saying that you're wrong because of
I don't
that.
understand what I'm
I'm
talking about because
saying
you
that
don't understand what
neither
I'm
one of
saying.
us are qualified to talk about that when we're here to talk about the shape of the Earth.
Okay. First off,
I mean,
I'm
you
qualified to
really
talk about
have
anything I
proof.
talk about.
Let me ask you a
As long
question.
as
Do you have proof that dark energy does not exist?
do I have
Do you
what?
have proof that dark matter does not exist? Do you have proof that one of those two things do not exist? Do you have proof of that?
Okay, so
Mathematical or
this is like
scientific? I'll
trying to
take
prove
either
God
one.
doesn't exist or trying to prove God does exist.
No,
You
no, no,
can't
no, no.
prove
I'm
something
asking
with no
you,
evidence.
listen to me. Listen, I'm asking you, do you have proof that either one of those two assumptions are wrong? Proof of it. Not an
There is no
assertion, proof.
physical proof. Again, mathematics prove
Okay,
things.
so
Physics
let's get back to what we can
theories
prove.
and
Let's get back to the things that we can prove, like
the
the
theory that I already
Okay.
proposed to you is that space-time has a viscosity, allowing it to have vacuum energy density beyond an emptiness of space. If space itself has energy density, if space itself has properties, you do not need to establish missing mass energy in the form of dark matter and dark energy to make the numbers work. Everything works altogether perfectly as long as you don't assume that space is this magic empty vacuum with no properties.
Stefan, nobody thinks space is an empty vacuum. Okay, first off, people that think that don't know what they're talking about. Second, nothing, absolutely zero to do with the physical geometry of the planet that we have our feet on right now. So let's talk about that. You okay with that?
The physical geometry of a flat 3 torus when looking at the sky, the only difference is the physical measurement on the ground of curvature. We're not talking about, see, the difference is you keep trying to talk about curvature of light. I'm talking about the physical curvature of the Earth, which is
curvature of light. Are you kidding me? I'm talking about line of sight. I'm talking about seeing something relatively close to us, no matter how far away it seems like it is. It's relatively close to
light not travel in straight lines.
Okay, so can I get back to my proof real quick? Yes. Okay. So, I guess bring that back up. Picture 3. So the calculation flat Earth are pretty simple. Using basic trig, we can calculate the height of a satellite to be 330 or 3,334 times tangent 55 degrees or 4,761 kilometers in elevation. The second calculation is for the globe Earth. Calculation is a little bit different as it needs to account for the curvature of the. Okay, so now if we'll go to the next picture, and that'd be picture 4.
If space-time itself is curved and taking a curved path, will that result in the same mathematical function as it moving to a curved globe surface? Yes or no?
So
yes or no, will the math move both ways?
I'm not really paying attention to what you're saying at this point to get through my proof. Can you allow me to do that? And then I'll answer your question.
Man, I'm telling you right now why it doesn't work.
Really think that so you're pushing the patience here, Stefan. I'm trying to be cool about shit. Check it out. Do you really think that we fucking live on a basketball-sized Earth with curvature of space-time around us, the side like tightly wound around this basketball, and that light simply follows this tightly wound loop around the basketball from one toroidal side to the other? Is that what you truly think is going on? Because that's what you're making the assumption for, okay?
Light is following the path of the curved space-time, which is spirally displaced into the center of the
this would be absolutely incorrect. This was the way the Earth was shaped, and every single one of my measurements that I'm going to be showing would be absolutely incorrect. This is based on a three-dimensional geometric shape in local space-time, okay? There is not this huge curvature that we need to take into account of space-time. All right, we're dealing with line to a satellite that's simply 30-something thousand kilometers away. It's not even that fucking far. Okay, so will you let me get through the proof and then attack my proof when I'm all said and done? You can go back and you make your notes and go back. All right, so in this picture, I'm showing you all the angles necessary before we do all the calculations. Now, if you need me to, you seem pretty intelligent, but if you need, or you seem somewhat intelligent enough to understand the trigonometry functions that are involved with these angles. Do I need to go over these with you? Or are you okay with that?
No, I'm aware of it. I'm okay with it, and I understand why that the trigonometry on the globe will work for positioning satellites, and a 3D linear flat Earth will not.
Okay.
Can we continue?
So, all right. Well, then I guess we'll be doing this for the people out there. So, okay. So now we're going to calculate the height of the satellite. We go to pick number 5, please. Okay, so we are using the scientific consensus radius of 6,371 kilometers. Now, if we apply trigonometry, we can calculate. I'm gonna start going through these but we can calculate y1 to be 3,185.5 kilometers by multiplying the radius times sine 30 degrees. Same can be done to get d1, except using cosine instead of sine. E1 equals radius of the Earth times cosine 30, which comes out to 5,517 kilometers. We can calculate the angle that we're going to be measuring, but it's kind of tricky because we also have to take into account the curvature of the Earth. So I used points where they were in exact cardinal directions, so easy for everybody to visualize this curvature we're having to deal with. But we can actually use any point to calculate a proper height of this satellite. Now, we do this by getting the distance between the sub-satellite point and observation point and divide that by the circumference of the Earth, then multiply it by 360 degrees. Okay, so you're familiar with me with what I'm doing, right? I'm building a 3D model with a sphere on the outside, with a radius of 6,371 kilometers. Are you following along so far?
Sure.
Okay, so when we get the information from the satellite company, it says that we need to have the elevation 55 degrees. Okay, that's 55 degrees on the horizon. And we also need to add the 30 degrees of curvature that goes in when we take measurements. So that ends up giving us the angle of measurement that we're going to be calculating for to be 85 degrees. Okay, now we go to the next picture, picture 6. Okay, so now that we have these numbers, we can calculate D2, D3, and eventually H, which is what we're actually looking for. We're trying to calculate the height, and this is from the sea level. So D2 is simple. It's the radius of the Earth minus D1, which comes out to 853.6 kilometers. And next we calculate D3, and that's equal to Y1 times the tangent of the angle, which is 85 degrees, I'm sorry. So that's 3,185.5 times the tangent of 5 degrees, and that equals 36,410.4 kilometers. You have to, of course, take out the, what was like 800 and something, and 853.6. We got to take that off of that number, and that leaves about 30,556.8 kilometers above the average level on Earth. Okay, now the prediction for these satellites are about 35,000. So this matches up pretty close to what the predictions are saying. Now will you go to Pix, please? Now, to save us from doing this a whole bunch of times, I went ahead and did the calculations at 5 degrees, 10 degrees, 15, 30, 45, and 60, and have put them on the screen in front of us. Now, as you can see, when we use the globe Earth model, with the one that we all live on, calculations come out to roughly about the same height. Between the highest and lowest calculation, less than a difference of 1,000 kilometers. And mostly we can do this to just the truncations of mathematics, like cutting off or not being able to measure a degree all the way down to the exact degree. At some point we have to we're limited by it or by the equipment that we're using. All right. So next slide, please. Picture 8. Okay. So I've also done this for flat Earth and taken out time to do the calculations for you guys. Anyone could see. Can verify that these calculations can be done using any online lat and longitude distance calculator to find the distance between the 2 points. And like I said, multiplying that number by the tangent of the elevation gives us the height of the sun. Now, as you can see on this thing, it's around the first couple of measurements are at about 5,300. Once you start getting away from the sub-satellite point at further distances, the elevation drops significantly. Now, nobody can explain this on a flat Earth. There's no perspective, nothing that explains this. This is a simple observation that proves that the satellite must move or the geometry of the Earth is flat. Now, what do you have to say about that?
Just like motion could be relative, will the mathematics work both ways, whether it's a flat Earth and curved path, or whether it is a curved surface and a straight path?
It wouldn't.
It wouldn't.
Nope. Because you when you're talking about line of sight, okay, when you start to move and you take different measurements and you measure this thing in a circle around it, right? You get to at which that numbers are not going to make sense. Like how would light bend to make it look like it's a sphere without it actually being a sphere? Like how would that reduce where the satellite appears to be?
Because again, we're talking about space and time. You're thinking of, again, straight lines, straight linear time. The whole idea is that, again, time being the rate of change or displacement in the system, that as you watch at the North or South Pole, everything spin above you, the star trails, what you're seeing is the spiraling space-time being displaced into the axis of the Earth, and again, into the Earth's center of gravity. So it's spinning
that
through.
Sounds fantastic.
You don't see all that spinning all at
that's all it is. You understand what I'm saying? All this that you're saying is very fantastical in nature. It's a fantasy. It's like, hey, look what I drew up. I drew up how light makes circles around Earth, and all it needs is these lines of space-time to circle the Earth in this manner. And then look, it's so beautiful. Where's the proof of any of this?
It's funny if you start doing that and applying it to every scale, that you get physics that work at every scale, and you don't have massive divides between relativity and quantum mechanics. You don't have massive, things that you have to make up for the cosmological constant not to be off by a magnitude of 120.
I know you keep bringing up the differences between general relativity and quantum mechanics. Do you understand what's wrong with it? Do you understand why there's a problem with general relativity?
Metric. It's the same as I was talking about before with water going down.
No. Hold on. You're not in the question I'm asking you. Stefan, listen to the question I'm asking you. Do you understand what's wrong with general relativity and quantum mechanics, where there's a lack of connection between the two? Do you understand that?
The biggest discrepancy, again, is the quantum gravity time paradox. I'm not even talking about the fact that a black hole in singularity would supposedly have infinite gravitational fields, and that's a problem. So, I understand. I'm talking about the bigger problem to me. Please let me respond, man. Okay, so the biggest problem in my mind is the time problem. The fact that in quantum mechanics, time is a fixed metric, and in relativity, time is relative. Okay, that is the biggest problem. And that is solved once you assume time as that rate of displacement. Because like I said, if you think about it like water going down the drain, if you have a bigger drain, you're draining more water faster. A gallon is still a gallon. It's just going down the drain faster. When you're measuring time as a metric...
What does that have to do with the shape of Earth? You don't understand. Nobody, the things you're saying are just hypothetical. There's not. You're like, hey,
Everything is
picture it this way, picture it that way, picture it this way. Give me
That's
proof of
what
anything
science
you're
is all
saying, and I
about.
will be.
And science is about presenting a hypothesis and then someone else falsifying the hypothesis. Nothing you
Okay,
have said
so
has
do you have a way of testing this? Do you have a way of testing this?
And just to let you guys know, let me break in just for a second. We've got probably a little over 10 minutes left before we have to wrap this show up so that we can get started on the part 2. So just be thinking about that while you're going down this. Don't start another.
I wish you would talk about the shape of the Earth, man. That's what I'm here to talk about. I've given you one proof. I haven't even got to my second proof. I've only one proof of what it is, and my proof matches up perfectly to the point that if you don't do you believe that I'm saying that I can actually pick any point on the face of the planet and get a elevation of the satellite in my longitude and latitude that's going to be somewhat similar to what not just what they say the height of the satellite is, but what every other measurement that I make using this my model. I mean, do you have, if take your model and the way you believe, could you, without having someone tell you where to look, would you be able to use to say, let me find this satellite? Or would you just have rely on somebody who actually believes the Earth is a globe to get the correct information? That's what my point is what you offer is no prediction.
Work identically. That's what you seem to fail to understand. Works identically in both models. It's not using somebody else's math.
No. I asked you, using your model, could you pick any place on the Earth and calculate what the height of that satellite is? Could you even find the satellite?
Of course.
No?
It's identical.
You could use toroidal mathematics to find the light. Please do. Please show it. We'll take the next 10 minutes because it would take me 3 minutes to believe the height of the satellite with any point on the Earth.
Put up your picture of the calculations of the globe. I don't think you understand what topologically identical in 3 dimensions means. It means literally the geometry and trigonometry to the surface from outside is identical.
I'm not sure you understand the difference between hypothetical and real. Everything you're saying hypothetical with no evidence to back whatsoever. You spouted out a few things about quantum mechanics and a few papers that nobody's even disagreeing with you on because they don't deal with the shape of the Earth, and number 2, they talk about things that were proven in 1920.
Well, I got into about page 3.5 of the 10 pages that I had written of notes. In terms of getting to the point I was getting at,
But the shape I'll give the rest of the time if you can prove to me that the Earth is not a globe. But I would like to prove that particular point. What is the shape of the Earth? Is the Earth flat?
Before,
is it a globe?
10 times, there is no such thing as a physics proof. There are mathematics proofs. There are physics theories. There are good theories that are backed by sound evidence and good interpretation. If you want to attack the interpretation of the data, you're welcome to. That's what
I just use math only. I just use math only to prove to you that I can absolutely make a prediction based on the shape of the Earth. Okay, to find the satellite without anybody telling me that.
You proved that the math equation worked within the parameters that you gave, which were limited to proof.
No, man, come on, dude. You can't have it both ways. You just said none of it was a mathematical proof. It's all a physics proof. It's all science proof.
No, I
just proved to you mathematically that I can build a model.
You did a math proof, but your math proof is not proof of the globe. Your math proof is a math proof that those numbers work for that calculation.
Tell me any other shape that all these calculations would work so perfectly on.
Again, going back to the point,
toroidal flat Earth.
The math proof, not the physics proofs, but the math proof will work on both models.
Ring your bell.
No, and you are a fucking idiot. Because both of those would not work. First off, you couldn't use a flat Earth predictive model to tell me where that satellite is at any point. I could not say, and hey, how about explaining this? Why on the other side of the flat Earth, on the other side of the visible horizon, can you not see the satellite? Because there's nothing to say that radar wave wouldn't propagate all across the surface. But we're not going to talk about all that.
Three-dimensional curvature. that you're observing. You're observing curvature. You can't see forever because the light is not straight. The light, again, follows the geodesic into the Earth itself. The fabric is curved. What do you think warp space or curved?
No, why does this not happen? Why doesn't light just fall into the moon or fall into the sun, light from other stars? It's again, if you would tell me, explain to me what the shape of the Earth is in your mind and be able to use proof, mathematical or otherwise, I'd be more than willing to let you try to convince not a globe with that my math is wrong based on
we're gonna have to kind of
search.
one
last
let
thing.
me just
Search, put in the flat torus in the 3 sphere. Okay, topologically identical in 3rd dimension, which means every mathematical proof for the globe works identically to a mathematical proof for a flat torus.
How would I be possible to make a subpolar flight, like one of the flights over the South Pole? How is that even possible if the two sides aren't touching?
And right now we're gonna go to kind of like a closing statement. You can incorporate that if you want to, Stefan, but we're going to let you guys now make your last pitch to the people who are watching based on what they saw tonight. So we'll start with you, Team Skeptic, if you want to wrap up your position and your takeaway.
Yeah, I really was hoping for, no offense, Stefan, it was a great conversation. I think you have you be honest with you, man, if you think the Earth is flat and you're wasting your time learning all this really cool stuff, because everything you're talking about is really cool science stuff, and if you just keep learning that stuff, that's good, but you need to leave that nonsense, because the Earth's not flat. No matter how you want to build a fantastical universe around it to make it flat, if you simply use everything you know about it being a globe, if you act as if it's a globe, then you're going to be able to make accurate predictions based on that model. And you can still go forth and learn all this really cool science stuff trying to learn. And that would be my advice to you. I appreciate it on, but you didn't offer anything regarding the shape of the planet. It was very unfortunate for me, because I was totally prepared to argue the shape of the planet, these hypothetical theoretical physics theories or ideas, I guess. Other than that, I think that you're an idiot.
Okay. Stefan?
I don't know. Like I said, go to your Google bar, type in the flat torus in the 3 sphere. It's written by a geometry professor at Brown University. He very clearly lays out the topology and how they are identical. And again, this is already been proven. So all the math proofs, the idea that the concentric circles around the poles get bigger south of the equator is fallacious. Again, it can be flat in 3D, it can be curved in 4D, and it can still have concentric circles that get smaller either side of the equator with 2 poles. And
then it would still be a sphere.
The whole no, it's not. The whole point. Geometrically, are topologically identical, but they are distinct, and that's the flawed. Like I was talking about, mutual exclusivity that is assumed that because it curved, it has to be a sphere. It has to be curved in three dimensions. And so, coming back to the whole argument that this theory works better at every level, you get to the ultimate hypothesis that the universe itself is almost a nested hypertorus at every level, which, because we only have a limited 3-dimensional perception of, we see, essentially as flat at every level, when there is really this toroidal curvature through space that we can't observe. That's it.
Is that good? Okay. All right. Okay. We had somebody that was watching that wanted to come in and say a few words. Are you there?
What the fuck?
Right.
Like, seriously, what the actual fuck So you're telling me if it looks like a duck, quacks like a duck, pretty much has feathers like a fucking duck, you're going to go forward and say that's not a duck because some obscure reference to quantum mechanics? Tell me, do any of the handful of scientists that you quote from, do they think the Earth is flat or no?
Most of them would subscribe to what would be either called a multiverse or a hyperverse.
Do they think the Earth is flat or no?
Probably not. I haven't asked them.
Probably not.
But
So
Probably
what are you
not.
seeing that they don't? So what are you seeing that they don't?
It doesn't matter. It's
No,
irrelevant.
it actually
to the
does because it's your opinion I'm asking for. So actually, it does matter what you say about your own opinion.
Sorry, repeat the question.
Okay, what are you seeing that they are not seeing? Okay, if you're quoting from all these brilliant scientists that they know their shit and they're not, subscribing to this idea that the Earth is a giant space pizza, what are you seeing that they are not seeing?
Maybe a larger picture rather than trying to place it into compartmentalization, which most of science does nowadays. People get very specified in their field, and they have a tendency to get a singular vision of one part of science, which excludes many other parts of science. My question to you would be, what did Einstein see as working as a patent clerk that all the other geniuses that had diploma, he didn't graduate high school, so what did he see that everyone else didn't see that he was able to come up with this theory? Who knows why people come up with it?
I know exactly what Einstein also thought. Einstein also thought that the Earth wasn't fucking flat.
You're getting really upset about this. I'm going to refer back to another, prepare for this. I watched maybe one video from the Team Skeptic interviews or live chat, and you were talking to somebody, Peter and Pete, and you're talking about that even though the flame burned yellow, you could measure the wavelength with equipment beyond what our perception is. And yet here you are trying to argue the validity of your perception.
No. Hold on. Don't misrepresent me on that, because that's not what I'm saying to them. I was saying that we can see the light as yellow, but what we can't see is absorption and emission lines. Okay, that's what I was saying. Use these other equipment,
we have
stretch
equipment
out the light spectrum so that we see the individual missing wavelengths of the light. That has nothing to do with
equipment, because
we're going to do a part two.
Is not the actual reality. Our
you actually don't need specialized equipment.
Hang on.
You don't need specialized. You don't need specialized equipment to figure out that the Earth is actually round.
How about we do this? Next time we'll have him on. I'm happy to address a lot of things that he talked about, because he's not actually wrong on a lot of things he said. I'm going to tell you guys right now.
Yeah,
there's a lot of things he said that is very on point, but it's just completely irrelevant. But we can get a physicist on here, a highly trained physicist. We know a lot of them. And if you want to talk about, I especially would like to get into the gravitational stress tensors you're talking about in relationship to the dark energy, because I know something about that, because we're going to be doing a hangout on that soon with a couple people, including an astrophysicist. If you want to do that on this channel, that's up to Kyle, but let's save that for another episode. Would you agree?
I'm fine with that.
Okay. Because I think you have validity there. I do agree that you can eliminate dark energy and still have a compensation for the positive stress tensor curvature on the Einstein's field equations. That's essentially what the dark energy is taking the place of. It's in the negative portion of basically saying pressure is equal to negative energy, such that if you have positive curvature because of mass, the negative curvature is going to be through the dark energy. Would you agree with that? To balance it.
Yeah.
That's what he threw in a fudge factor. Yeah, because Einstein threw in a fudge factor, cosmological constant, for that very reason, and they are related to each other. All right. So, anyways, I think we should say that to another time.
Real quickly. I'm gonna read these super chats real quick, but before I do, I want to say thank you to Stefan, Team Skeptic, and for the brief cameo from Reds. Thank you for coming on and having this discussion. Sorry that we're having to kind of rush through, but we've got the part 2 for the show coming up in about 10 minutes, so I need to get through these super chats really quickly. But thank you both for coming on, and it was fun. We'll have you.
Where's my glass of bleach?
I'm always around, man. Thank you for having me on, and I appreciate your time.
Yeah, man. Take care. Enjoy your weed. Okay.
You know it.
let's see. Okay.
And I agree with Steve. A lot of the stuff he was talking about, I was like, yeah, I mean, you're not wrong, but it has absolutely nothing to do with the shape of the Earth.
Yeah,
Like,
and
we-
what he
right,
was
you-
talking, the reason he was so adamant about this, like the point Garrett conjecture, he was trying to relate things that are isomorphic or homo have a relationship between a 2-dimension and 3-dimension, right?
Homoerotic.
Right?
That's the word you're looking for. Homoerotic.
No,
Vandy,
homeomorphic, but close enough.
Vandy says, not the brightest crayon, or not the brightest cookie in the crayon box. That doesn't even make sense, but cool, Vandy.
Maybe that
Do you
was the
still think
point.
that was sarcasm, Reds. You're
Are-
showing so
are-
much
are you-
Jeranism now.
Are you sure? I don't know. Maybe I'm just a little on edge. Maybe it's because apparently
Maybe.
what I need to do now is put a fucking plate with 2 slits in it in front of my Nikon P1000, and then magically the Earth will be fucking flat. It's been a space pizza the entire time. Fuck
need
my
Xanax.
life. Fuck my
You
kids.
need
Someone is
Xanax.
over
Fuck yeah.
caffeinated.
Somebody give
Someone's
me Xanax.
over-caffeinated.
Right. Hero
Not me
32132. Did you guys get get a Markov bot to read a bunch of ArcSiv papers, and you're having that debate, TS Team Skeptic, because it sounds that way. Yeah, it was a lot of words. Ghostly Enigma. He has no bloody idea what he said at all. And at the start of this, as far as I know, most of what he says was bullshit. Macabre. Malefica. Macabre Malefica.
Malefica.
Man, I'm telling you.
Malefica.
That mixed look of bemusement, incredulity, and pain in Steve's eyes is heartbreaking. Thank you guys so much for putting up with this shit for our entertainment. Please use this for some hard liquor. Thank you.
Things we did for you. Thank you.
Peter Miss Prime, dark energy and dark matter have been measured. We just don't know what exactly it is.
true.
Seth Rhino, if light bent so much due to gravity, we would experience gravity's acceleration much greater than 9.1 miles per second squared.
Meters per
Light
second
does bend
squared.
because of gravity.
Yeah, that's what I meant. I'm sorry.
Yeah, meters per second squared. But light
thank
does
you for that.
bend. I mean, he was right about that. I mean, in geodesic
Yes.
space, the fact that you have light traveling the shortest distance, which would be a line in the geodesic space, because the universe is curved, right? So that exactly was happening. The photon's taking the shortest path between 2 points in a line on a geodesic curve.
And
Sigifredo-
let me just say this.
we
Let me
see that
just
as
say
bending.
this. Hang on, let me just say this. And also, for light to curve in the way that he's saying because of the curvature of space and time, wherever the fuck this guy was pulling out of his ass. Basically, welcome to Earth, aka a fucking neutron star.
Yeah, right.
Yeah, I
You all
think
are
it's a
dead.
little-
That's what they're thinking.
You
I
all
think
are
it took it to a
dead.
little
Space-time
extreme,
just-
too.
You all are
Yeah.
now fucking dead now, because guess what? The Earth ain't the Earth. It's now a fucking neutron star.
Donut Earth. Well, at least we finally made it to Donut Earth tonight. I feel like that's an accomplishment. Now all we need next
Donut
is Hollow Earth.
fucking
We need
Earth.
We need
Oh,
Hollow
my
Earth.
God. Yeah.
Okay. By the way,
frustrating.
I have actually a lady coming. I'm talking to her now, but she believes that mountains, get this, are really trees. Now just think about that. Okay,
What?
just think about that.
I've seen that. Yeah. No, that's been around for a while. Was that the whole Devil's the tower, Devil's Tower that was in Wyoming?
No,
that it was this big tree. That one? 'Cause
Yeah, that is
basically that
is
was
a thing. That's the Bible thing, though. That's for giants. She's taking a different approach, and this video came out this past week. I'll send you the link, Steve. But it's fantastic.
Oh, good God.
Since Fredo Sarabia says, why are these calculations using straight lines, limit of infinity, when lines on a short scale are supposed to be bend following a tangent, or supposed to bend, I think is what he meant, following a tangent. Oh, more tangents. Cy Strike for $10. Thank you, Cy Strike. For Team Skeptic's display of patience, I'll agree. John McGee says, Tokes to oblate spheroid Earth. Amen. Who's Your Atheist says, hashtag Team Cunt wins again. And I think I just saw one more come in.
Yes.
Yes. Chris E says, chicken, duck, book. Chicken, duck, book, nail, dirt, la la la, Yahoo, I win. That is the greatest super chat ever. Okay.
It's la 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 la. Yahoo, I win.
Yeah. Thank you. Thank you again.
I caught something just a second ago. You said you had a woman coming, correct?
Right.
With that first.
Just leave it at that. Do not add any
Yeah.
context.
That's
Nice.
for you.
Nice. Nice. I like that. Cool. That's a good way to end it, actually. Leave the stream with the women coming. I like it. Okay, so we'll see you here back in 10
Good.
minutes. Thank you again to Team Skeptic, to Reds, and to Stefan for braving the Lions Den for the first time. I think he held up. He did a lot better than I thought. He held up a lot better than I thought.
Well, he did good. He
actually.
did good for what he was taught, but he did shitty for proving the Earth was flat.
Oh
Yeah, no, he didn't relate.
yeah. In terms
He
of his
didn't relate.
argument, it was crap. But I mean, like in words strung together in sentences that sound profoundly, he did amazing.
Hashtag
Not sure he said
one
anything.
donut.
Not sure he said
He's done
anything, but,
a lot of research into shit that you can't prove or disprove yet.
It
which
was
is
very
where the money's
profound.
at. Oh yes.
Profound.
Shout out to Rick.
Very
We'll see you
profound.
guys in 10 minutes. We'll see you guys in 10
Y'all
minutes.
take it easy.
Non sequitur. Your facts are uncoordinated.